If this trend were to continue, which expression could the company's chief financial officer use to approximate their monthly? Okay, so I'm going to definitely go to a separate sheet of paper on this one. Right now, we have the yearly growth. So we have the final amount equals the original amount, 1 plus 0.0525 to the t over 1 year power. They want us to change it to the 1 month power. So essentially, we just have to plug in 1 month and recalculate. The problem is 1 month and 1 year are different units. So if I make this t 1 month, is it easier for you to turn that into years or either easier for you to turn the years into months? Years into months. So all you have to type in is 1 plus 0.0525 to the 1 over 12 months now. And 1.0525 to the 1/12th power gives you a monthly rate of 1.00427. Now, 2 of them have that. Okay? M is the number of months. So this one is technically over 1. So that increase happens every 1 month. This one has it over 12. So technically this increase is happening every 12 months. Which is it? 3. Very good. We just found out the monthly rate. That's the rate of increase every 1 month. Any questions on that? It's familiar, right? Next, number 22. Which value to the nearest tenth is not a solution of P of x equals Q of x if P of x equals that and Q of x equals that? What are your thoughts here initially? This says P of x equals Q of x. What'd you say? Set them equal to each other. And we can do that. So 22. Does anybody have a different idea? Because I do. Just use your calculator. Absolutely. If I didn't think of that and I did it by hand, I'm trying to see if it would still work. So go ahead, you guys graph it on your calculator while I do this. The only way we will be able to solve this algebraically is if it's factorable. And by grouping, it's not working by grouping. So algebraically would be tough, which actually makes sense to me because my answers are all intense. Usually grouping is going to lead to nice answers, like whole numbers or 2.5, something like that, if factoring works. Just be careful of your, can I steal your calculator once you have this in, Connor? Be careful of the language here, which is not a solution, which means there are 3 of these are solutions and only 1 of them is not. Yes? Which makes sense because it's a cubic polynomial, so 3 solutions make sense. So when Connor first graphed his, he's only seeing 2 solutions. He found the intersection of the first one, so we know negative 3.9 is a solution, which means it's not the right answer. If you do it again, second trace, intersect, and he moves over here, enter, 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 we'll give him negative 1.1, so we know that that's an answer. His other one is off the screen, so he needs to change his window. He needs to look up further, yes? That's the y-axis moving up. So on your window, your y maximum, I'm just going to go to 20 and see if that does it. And then try to find my intersection. And you can kind of see my options are 2.1 or 4.7. Obviously, I would do second trace intersect again, but it's clearly more around 2. Yes? So probably 2.1, I would guess, and then that's the only one that's not a solution. Okay, use your calculator to your advantage, especially on a multiple choice. Okay, 23 gives us the population for Jamesburg in 2010, 11, 12, and 13. How can this sequence be recursively modeled? Two of those are not even recursive, so which two can we immediately cross out? 1 and 2. Those are both explicit. This one's an explicit exponential growth. This one is an explicit arithmetic growth. Those are explicit. Recursive requires a subscript of n minus 1. So they both start with a first year of 250,000. This one is taking the previous year and using a multiplier, and this one is taking a previous year and adding 937. So clearly this one adds 937, but does that pattern continue is the question. So 250, 937 plus another 937 would put us at 251, 874. That's a little bit off. And if I add another 937, it'll put us at 252, 811, where this one is. So it's not exact, but the fourth term is off by 11. Yes? So this is off by 11 when you get to the final term. If you use a constant multiplier, 250 times 1.00375 gets us to 250, 937.5, so that's off by a half. If we multiply again by 1.00375, we're off by a half. If we multiply again by 1.00375, we're off by 1. So which one's better? 3. This one's only off by 1 by the time you get to the fourth term, and this one's off by 11. Okay? A little tricky because they show you that 937 exact growth on the first one, which makes number 4 tempting, but if you see it through to the fourth term, you see that 3 is better. So we'll stop there. I have one thing to pass back to you and tell you before you go. The solutions to these are online, but the work for the multiple choice is no longer going to be given to you. Okay? So if I go on to my webpage quickly.